Hello YouTube, my name is Alex and this is an introduction on how to make your own Tesla lights. So if you look up Tesla lights on the web, you'll see several different types of Tesla lights, such as the biocharger, Tesla energy lights, and they're all extremely expensive and they all have their benefits and their downfalls. So the main idea behind Tesla lights is to create um, a setup where you have the seven noble gases excited by high frequency, high voltage current. And the reason for this is because Tesla said that when you have seven noble gases and they're excited by high frequency, high voltage current, then they are giving off light and radio waves that are corresponding to the frequency of your seven main chakras. So it is a subtle energy healing device, and I'm going to use this one in conjunction with my Lakhovsky multiwave oscillator, which I will do a video on soon. So here you see my messy, ugly setup, and the reason this is such a mess right here is because what I bought was 6 induction coils, these here. And induction coils, they were just cheaper, which is the reason I bought them, but if I had the money, I would have bought 6 solid-state constant wave output Tesla coils. Because induction coils spark to ground, and when you have something that sparks to ground, you need to hook up the ground wires, and it becomes sort of a hassle. So I'm just going to go through some of the engineering problems I had with my preliminary test. And in order to do that, I'm going to start off by showing you guys which different gases I have here. Now, I don't have all the noble gases here, but in my final version, I hope to. So I'm going to show you guys the gases I have here. This one here is xenon, and I'll explain why I disconnected this one from the terminal in a second. This one here is air, which is different from O2, which that one over there is, because this one contains nitrogen as well. And I have water vapor, argon, and helium right here. So I removed xenon and argon because those are the two lowest resistance gases I have in this setup, and because of that they were the only two lighting up, and that was sort of a problem because what I want is all of them lighting up. And I connected each of the terminals of my induction coils with tungsten electrodes in order to get a combined 280,000 volts instead of each of them running at around 40,000 volts. The idea was that if you had 280,000 volts running through, then all the lights would light up at once, but that was not the case. So before I remove the tungsten electrodes and run each induction coil through the tubes themselves, I am going to try adding a single solid state unit to one of the electrodes in order to create a constant wave output for all the coils to share in hopes that they will all light up. So I'm going to fire it up and show you guys what I mean when I say that xenon and argon have the lowest resistance. So I have a surge breaker here, surge protector, so that I could hook all the Tesla coils up, and it's using quite a bit of current. So here I've removed the two lowest resistance gases, which are xenon and argon, and you can see my helium bulb lighting up. And I can adjust the frequency on the Tesla coils here using these knobs in order to get a faster flash. And water vapor is lighting up a little bit, can't really see it, and that is because water vapor doesn't have a very bright light, whereas helium's light is quite bright. And so I'm just going to show you what happens when I pop xenon on here. Here you see xenon lighten up, and helium stopped lighting up because xenon is the path of lowest resistance to ground now. And as the connection with xenon becomes less and less direct, you'll see helium light up more and more. I'll show you that. So, argon is the same deal. This is my argon tube. I'll just pop it on here, and you'll see that it lights up purple. and my helium stopped lighting up. Water vapor is no longer lighting up, and O2 and air are not lighting up either. So that is why I removed argon and xenon at this point in time. Right now, I'm considering taking these tungsten electrodes out because when I do that, the lowest resistance gases are the only one that light up, whereas if I had each induction coil powering each tube, based on my previous experiments, I know that each tube will light up. So I was a little surprised to see that, considering that I have a pretty immense electrical pressure of 280,000 volts between all these induction coils. But I intend to throw a single solid state constant wave output Tesla coil on one of the electrodes in hopes that all of the lights will then have enough electrical pressure to light up. So when you're making your own Tesla lights, you want to get several different either induction or Tesla coils, and I recommend, if you can, getting solid state Tesla coils with a constant wave output, because when you have a different induction or Tesla coil for each light, then the current has nowhere else to go except through the light. And that's why I have these copper wires here wired to ground, because my induction coil would otherwise spark directly to ground if it wasn't for this clay and this copper, making the tube the quickest and lowest resistance path in order to get to ground. So that is one way to do it. If you had a solid state Tesla coil, you would not need to hook a ground up on the top of your spectrum tubes. And I got these spectrum tubes and the induction coils from AmazingOne.com. They have other Tesla coils that are solid state, like the one I will be posting in my next video. And they also have the spectrum tubes for sale, which are excellent. They're the same ones used in Tesla Energy lights. So that is just a quick introduction to the engineering problems I've encountered so far. When I throw a constant wave output solid state on there, I will post another video depending on what the results I get. And if I don't get any results, I will be removing the tungsten electrodes so that they each have their own Tesla coil terminal to go through, instead of connecting the terminals here in series like I have. So that is my quick introduction to making your own Tesla Energy lights. The reason I'm posting this is because there is nothing on the internet about how to make your own Tesla Energy lights, and I think that's a shame, because not many people have $8,000 to $20,000 to spend on units like the Tesla Energy lights or the Biocharger, which claim that they have, specialized outputs and all that, when really there's nothing very special about them. I have seen the Tesla Energy lights in person, and although I did feel the energy quite a bit, and I would consider myself sensitive to subtle energy, I did not enjoy them as much as I have enjoyed, the process of creating my own. And I have a feeling that when I'm done with my setup, I will have a similar effect between my Tesla Energy lights and the Lakhovsky multi-wave oscillator, which I already own, to the different types of multi-wave oscillator outputs that units like the Biocharger have, using the Rodin coil as their multi-wave oscillator, which simply does not work as well as the Lakhovsky design. So that's my quick introduction. Thank you, YouTube.